Okay, please confirm that everyone can see my screen.
Yes, it's visible.
Okay, that's good. Bismillahirrahmanirrahim. This is a part 2 of our calculations session. Please mute yourself. This is the part 2 of our calculation session. In the first session, our main focus was on allegation method. Of course, it was important, and you should expect some questions from allegation method. I tried to clear the concepts. I have tried to simplify things, and I have given you exact. Second, where is this resonating? Okay, I have given you exact 3 type of questions that you can encounter. In today's session, we will be focusing more on milliosmoles, milli-equivalent, and millimoles equivalents and milliosmoles. Apart from the allegation method, I believe that these are the questions that require more simplification. So I have added this in today's session. So there are actually 7 topics we will cover. Starting from the mass, volume, specific gravity, their convergence, simple questions. You can expect 1 or 2 questions from this part in your caps, and then we will go into the millimoles, milli-equivalents, milliosmoles. You should expect 2 to 3 questions, because nowadays we have seen that people are getting like 20, 15 calculations. So I am telling you on that that calculations. Okay, then we will go after suppository base. Then we will see molecular manipulations, then child doses, then body surface area and body mass index, and then we will deal with stock solutions. So starting with the mass, volume, and specific gravity. There is one simple formula for this. That is density is equal to mass by volume. One thing we need to understand is that the mass is in gram and the volume is in ml, milliliter. This is very important. Sometimes in question, the question tricks us about the units. Maybe they are giving mgs, milligrams, and we utilize the same thing. That will give us wrong answer. So we should be sure about the units. Density is equal to mass by volume, that is gram per milliliter. Okay, if we manipulate it, we are not going to use this directly. I don't believe we are going to use this directly in any question, but we will use its modified forms that are mass is equal to density multiplied by volume. This is simple manipulation. For example, we will take mass on a side, then the volume goes up with the density. Volume will multiply with the density. Same happens here. Mass is equal to density into volume. And the other thing we can make up from this formula is that volume is equal to mass by density. If we have to calculate volume, then the mass is going to be in the division of density. So is this clear? When I ask you, you should be raising your hands so that I would see that if this concept is clear. Raise your hands for those who have this concept clear. Muhammad Hukaz, one other, two other. In case you don't understand it, I will repeat it. Okay, there are a few hand raises. So this is the simple thing. Okay, now let's move forward. Here is a question that we are only going to be solved from the above formulas. That says what would be the weight in gram of 25 ml of arachis oil, that is peanut oil, the density. Please mute yourself. Okay, this is a very simple question. What would be the weight in gram of 25 ml of arachis oil, that is peanut oil? The density is given. Okay, the one thing, if they are giving you a density in a range, you will find a mean value. We will see about that. So this is about what would be the weight, and they are giving us the volume. So what we will do, we will use the formula that says about mass. right? We want to find the mass. What would be the weight in grams? So mass is equal to, we know that mass is equal to density into volume. So density is given here. Density of arachis oil is 0.09 to 0.909 or 0.916. So we have taken the mean value, that is 0.913. If they are giving you a range, take a mean value in between. And we have multiplied it with the volume, that is 25, and it has given us the mass of 22.8 grams, right? Keep an eye on the units, gram per ml. In the questions, we have the answer demanding in gram and the volume given in ml already. So we do not need to convert it. This is a very simple question. We'll move forward. We will see another question that says, what is the volume of 100 gram of liquid paraffin? And the density is given, liquid paraffin is 0.83 to 0.89. So what we will do, we will take a mean value of this density, that is 0.86, and we have the weight in grams, already in grams. If it's given in milligrams or micrograms, we need to convert it into gram. So it is, the formula goes like this one above, volume is equal to mass per density. Please mute yourself. Okay, the volume is equal to mass by density. Volume is equal to mass. Mass is given 100 grams and density is given as here. So how will you understand that a formula into looking at the question, you are going to understand how to solve it. And same principle applies to all type of questions. This is simple one, mass and volume conversion. Now, maybe they can give you a question directly to convert the mass in volume, or maybe this can be a part of a bigger question. Maybe they are talking about millimoles, moles, and at some part of the question, you need to change mass with volume or volume with mass. So you will use this simple formula in those complex questions. I hope you understand it. Then is another concept of specific gravity. Another concept of specific gravity. Specific gravity is just equal to density. If they give you specific gravity, they give you density, it's equal. You can use it in the formulas above. Now, the how to just justify this, that specific gravity is equal to density, we'll see. Specific gravity is equal to density of substance divided by density of water, that is 1. So anything divided by 1 is equal to the same thing. So that's why I said that specific gravity is equal to density. We will take a look at one question. For example, if the density of a substance is 0.91 and it's divided by 1, the answer is going to be 0.91, the same. So take a look at the question. The specific gravity of dimethicone, an ingredient used in this stage, is 0.97. The weight of the substance is required to be to fill a 200 milligram ml of bottle. So this is just a conversion of mass and volume. So we will take this specific gravity same as density and we will put it into the formulas that we have learned above. That mass, because the mass is required, what weight of this substance? Weight means grammage. So what weight is required to fill 200 ml of bottles? We have used specific gravity given here just like density, and we have our result. So this formula came from here that says mass is equal to density into volume. So mass is equal to density into volume. So in here 0.97 was given us as specific gravity, but we have converted it into density because we know that specific gravity is equal to density. So this was one concept of conversion between mass and volume. See, if there is any question on this topic, I can clarify it right now. Again, this is not going to be the simple question for you to convert mass into volume. This is going to be a part of a bigger question. Clear to everyone this simple concept? You can raise your hands to tell me that you, okay, I understood. Only one person is understanding this? Okay, we will move forward from here. Okay, the next concept is the main idea of this whole session, that is millimoles, milliequivalents, and milliosmoles. First of all, let me clarify some things. What are the moles, equivalent, and osmoles? We know about moles, millimoles, milliequivalents, equivalents. So let's see what are these things. So this is just about the unit conversion. Just like we convert gram into milligrams, so we can convert mole into 1 mole is equal to 1000 millimoles, equivalent equals to 1000 milliequivalents, and osmoles is equal to 1000 milliosmoles. So it's just like a unit of gram and milligram. That's it. Most of the times we will be dealing with millimoles, milliequivalent, milliosmoles, because these are the quantities we actually use in medications. Moles not so much. Maybe in your questions we will see both of these, moles and millimoles. But when I say millimole, I will be referring to like 1000 millimoles. Matlab, I mean mg and gram. Just like these two things, we have mole and millimole, equivalent and milliequivalents, osmoles and milliosmoles. It's very important because in the upcoming slides, I may be talking about millimoles throughout the question and maybe talking about the mole throughout the question. Okay, moving forward. The second concept I want you to understand is that 1 millimole is equal to 1 milliosmole. Subsequently, 1 mole would be equal to 1 osmole. So this is a stable connection between these two. 1 mole is always going to be equal to 1 osmole in conversion, and 1 millimole is going to be equal to 1 milliosmole. So this is the relationship between moles and osmoles. Now the next concept is about millimoles and milliequivalents. This is a bit different than the relationship between moles and this 1 millimole is always going to be equal to 1 milliosmole, or conversely, 1 milliosmole is always going to be equal to 1 millimole. But for milliequivalents, this is about the valency. If the valency is going to be 1, either plus or negative, doesn't matter. If valency is going to equal to 1, then this is going to be equal to millimoles equally. But if the valency goes to 2, for example, magnesium has a valency of 2, either positive or negative, any element, then there are going to be 2 milliequivalents in 1 millimole. Let me explain to you in an example. For example, this is sodium. Sodium has a valency of 1. So we can say 1 mole is equal to 1 osmole. Oh, my bad. There should be millimole written here because we are talking about the milliosmoles and milliequivalents here. So in case of sodium, 1 millimole is going to be equal to 1 milliosmole, and 1 millimole of sodium is going to be equivalent to 1 milliequivalents, because the valency is 1, so milliequivalent is also going to be 1. But when we see magnesium here has a valency of 2. So one millimole here is going to be equal to 1 milliosmole. As I have told you that the relationship between osmoles and moles are going to be always same. But as of the valency of magnesium, now there are going to be 2 milliequivalents here. If we go back from here, we say that okay, how many milliosmoles or millimoles are there in 2 milli equivalent of magnesium. So we will say 2 milli equivalent of magnesium is equal to 1 millimole or 1 milliosmole. So we can go back and forth with this thing. So this depends on valency. Only difference is with MEQ, milli equivalent, and that's related to the valency. We'll see about that in a few examples as well. Now here is a small quiz for you to tell, so that I know that you have understood the things. For example, the first question is, for a chloride ion or chlorine, 1 millimole equals to how many milliosmoles? Who is going to answer this? Yes, one. 1 milliosmoles. Yes, perfect. Yes, 1 milliosmoles. Why? Because the relationship between millimoles and millimosmoles are going to be the same. Well done. Okay, the next question is about the calcium. Now, calcium has a valency of 2, so 1 millimole is equal to going to be how much milli equivalents? 2, very good. 2 MEQ, excellent. So now a third question. Well done, 2 MEQ. The third question is calcium that has a valency of 2. It has 2 MEQ, means 2 milli equivalents of calcium are going to equal to how much millimoles? 1, excellent. So I'm going to repeat it one more time quickly for those who don't understand. Okay, excellent, excellent. The relationship between millimoles and milliosmoles are going to be the constant. No, 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 not 2 millimoles, Sajid Iqbal. I'm repeating this. The relationship between millimoles and milliosmoles are going to be constant always. So we talk about 1 millimole, that means 1 milliosmole. And even the relationship between millimole and milli equivalent is going to be the same in case the valency is 1. Valency of the element is 1. MEQ is going to change if the valency goes up. Either minus sign, either positive sign, doesn't matter. If the valency goes up, the MEQ goes up. So that's what happened here. In the first question, we have seen that chlorine that has a valency of 1, how many 1 millimole is going to be equal to 1 milliosmole. This is a constant relationship between two regardless of the valency. Then with the calcium, now 1 millimole equal to how much MEQ? 2 MEQs because the valency is 2. Or if we go back, so in the next question we have actually gone back, that 2 MEQs are equal to how many millimoles? The answer is 1, because the valency is 2. So 2 MEQ is going to give us 1 millimole. Mole is not mole is not disturbed by the valency. So we will move forward. There are a few concepts that you need to understand to solve these questions, like means related to milliosmoles, millimole, MEQ. There are simple three concepts that you need to understand. The first thing is you should be able to understand how this, yeah, you're welcome, how this equation is going to give moles, millimoles, or milliosmoles or milli equivalents. So we'll see. In this example, we have magnesium chloride. Magnesium chloride is 1 mole because this is a molecule. If we disintegrate it, this is going to give us 1 millimole. Now we are talking about millimoles. This is going to give us 1 millimole of magnesium regardless of the valency, because millimole doesn't take into account the valency. Then 2 chlorides. Why 2 chlorides? Because we have MgCl2. Anything written here in the subset is going to give us 2 molecules of chlorine. So 1 millimole of MgCl2 is going to give us 1 millimole of Mg and 2 millimole of chlorides. Anything written down here is going to give us 2 of the millimoles. Okay, next, milliosmoles. In milliosmoles, I have told you that this is same as millimoles. So what's going to happen? 1 milliosmole of MgCl2 is going to give us 1 Mg milliosmole and 2 of the chloride milliosmoles, right? Now the third thing, milliequivalents. Now this is going to be the same because this is one whole formula. Then this is going to give us 2 milliequivalents of magnesium because of this valency, 2 milliequivalents of magnesium because of the valency, and 2 of just like others because there are 2 molecules of chloride. So this is going to give us 2 MEq of chloride. This is the basic concept. If you know this concept, the other ones are easy. Other ones are just a formula and cross multiplication. You are going to solve any question related to this topic. So I will go forward towards the next concept. The next concept is about the formula that moles is equal to number of moles is equal to mass by molecular weight. Mass in grammage by molecular weight. As we do not need to write it down in a paper, this is not a theory paper. This is just an MCQ paper. We just have to select an answer. So you do not need to demonstrate the teacher that you know the formula. So you can customize it your own ways, right? For example, in my way, how I have memorized this formula is that number of moles is equal to gram per molecular weight. For me to easily understand it, to remember the units, so I have memorized gram per molecular weight. It's your own choice. You can go with mass, but you need to understand that this is in grams. Now, gram per molecular weight. I have told you that mole and millimole, even this is there is the same relationship just like we have with gram and milligram. Mole, millimole, gram, milligram. So what's going to happen is we find a shortcut here. It's not a formula written anywhere. So what we can do is that if we take the moles to millimoles, if we are dealing with a question that have millimoles in it, so we can customize the formula in our own way and we will change the mass into mg. Now we are playing at the same level of milligrams, just like milligram, millimole. If we play at a level of gram, then we will talk about moles, because in some questions you will be dealing with moles, in some questions you are dealing with directly millimoles, so you can directly use this formula and it's going to be all right. Number of millimoles is equal to going to be mass in milligram divided by molecular weight. So this is a concept, because in caps we need to take care of the time. It's not about theory. We do not have to fill half a paper. We just need to select an answer by doing any shortcut we can. So what's going to happen when we are playing with moles, osmoles, and equivalents? We will be playing with grams. If there is one thing different in different unit in our question, you need to adjust it. For example, there are 3 things in mole and one thing given in milligram. You change milligram to gram, right? Instead of turning everything down to milli level, you take it to the upper level, grammage level. We will see about this in our next example questions as well. So when we play on millimole, milliosmole, and milliequivalent level, you play with milligrams. So keep everything in same level. It's going to be very helpful for you. So this is the second concept with the formula and the level of playing, where at which level of unit you are playing. So the third concept is simple about the cross multiplication. This is not about the cross multiplication related to this topic, milliosmole, milliequivalent. This is general cross multiplication. So how cross multiplication works, we all know that. For example, if 50 gram of sodium is in 100 ml of water, then how much gram is in 70 ml of water? This is simple cross multiplication. So what we do, take x on one side and adjust the equation on the other side, and we will have our answer. This is the third thing we need for these kind of questions. If we know these 3 things, in all questions are easy for us. So if anybody have any question in this, because now next we are going to jump into the examples. If you say I will repeat it 10 times, no problem. Anyone who have any question in here? All right, seems clear. So now we will move forward into a simple thing first. Okay, we will see about the formula we are going to use for the conversion between moles and mass. These are the two things we convert in between these questions. So what's going to happen? How many grams of NaCl are equivalent to 1 mole? So I am going to hit 2 marks with one arrow in this question. I will share with you two concepts in the same question. How many grams of NaCl are equivalent to 1 mole? So we have a formula that we have read on the last screen, that is number of moles equals to mass in gram divided by molecular weight. Why we are taking everything in mole and gram? Because it's in the question. So we will stay at this level. Well, gram, mole, this level. How many grams of NaCl are equivalent to 1 mole? So this is the formula. Number of moles is equal to gram mass by molecular weight. So I have told you that we are not going to use this formula the same way. We will be using its alternate shapes. That is, we need mass. So we will take this molecular weight and multiply it with the number of moles. So this is how we will shape it now. Mass in grams is equal to number of moles into molecular weight. So we need to put it here, the values, number of moles 1, molecular weight is 58.5. The answer is going to be 58.5. This is one thing, that if we need to convert moles into mass or mass into mole, we will use this formula. Another thing, please focus that the answer is also 58.5 gram, which is the same as the molecular weight. See, so this is the concept. To take a shortcut in your Kaps exam, we can see if there is 1 mole of anything, this is going to be equal to the grammage of molecular weight. If we have 1 mole of anything, it is equal to, if we would be given the molecular weight, it is 1 mole of anything is equal to the grammage equal to its molecular weight. So we have proven this with the formula. If we are given anything, for example, it has taken into millimoles, that 1 millimole is equal to, then we will say, as we are talking about the milli levels, then we will say there are 58.5 milligrams in 1 millimole. Or if we are talking in moles, so we can easily say that there are 58.5 grams in 1 mole of NaCl. So where it's going to help, sometimes there are going to be multi-step questions. So in one step you have to find out this, that okay, how many grams are there in 1 mole of anything. So now you know that if there is a figure of 1 mole or 1 millimole, you should know the shortcut, that it contains the equal amount of gram or milligram of as of the molecular weight. I hope this is clear. So now there is a question for you guys. How many milligrams, now we are talking about milligrams and millimole level, how many milligrams of NaCl represent 2 millimoles? Without any formula, who is going to tell me? How many milligrams of NaCl represents 2 millimole? The molecular weight is given. Anybody? 117, yes. Why? Because we just simply need to multiply this molecular weight with 2. With 1 mole or 1 millimole, 1 mole or 1 millimole, this is going to be equivalent to 58.5 gram or milligram, depending on the level of unit you are staying with. And simply in the second question, it says 2 millimole. So here is 1 mole. Here are two things different. The number one is this is 2, and the second thing we are dealing with the millis now. So we are going to say if here is 1 millimole, the answer is going to be 58.5 milligrams. Otherwise, it's going to be, if it's in moles, we will say 58.5 multiplied by 2 in grams. We'll see about this. The solution, same formula, and we have manipulated the formula for our own purpose. And then 58.5 multiplies by 2, number of millimoles. Here number of millimoles 2 multiplied by molecular weight 58.5. This is going to give us the result of 117 mgs. So this is not going to be the same question in your Kaps exam, but this can be a part of a bigger question, and it sure will be a part of bigger question. So the thing we have learned from this slide is that we do not need to calculate through the by writing the whole formula. If there is, we are talking about a full mole or 2 mole or millimoles, means we have a full figure of 1 or 2 mole, 3 mole, 5 mole. We just need to use a simple calculator command to find out, okay, what is going to be the weight. We do not need to write down this whole formula. 1 millimole is going to be equal to 58.5 grams of NaCl. If there is another substance, just go with that molecular weight. Gram, sir, mass should be in gram always in formula? No, this is about units. Someone have asked that mass should be in grams always in formula. So I will repeat it one more time. When we are talking about grams and milligrams, make sure that you are playing at the level, the same level. I will go to the slide backwards. Okay, take a look at this moles, osmoles, and equivalents. When we are playing at this level, when there are these things given in your questions mostly, and you like to stay on this level of unit, you will be playing with grams. If you have to go into the millimoles, milliosmoles, and milliequivalents, if these things are dominant in questions, that you can then you convert everything into milligrams. For example, three things are given in millimoles, and one thing is given in gram. So what will you change from here? So you will change one thing to from gram to milligram to come at one level. Or if three things are given in mole, or three things are given in gram, and the fourth thing is given in milligram, then you convert that milligram into gram. So stay at one level in your question, and this is going to happen with you. In the question, there are going to be multiple units given. They will be talking about millimoles, and on the other hand, they are talking about grams. This is where the trick. So be good with the units. So convert, just come on one level, either on milli level, either on gram level. These are the two levels. With practice, you will understand this. So we will now go forward. This was the simple demonstration of change between millimoles and mass. Now the second thing is going to be a bit more complex. I will give you example of a few basic functionality of questions about how to solve these questions. When you practice, you will find some things added up on the top of the question, or maybe at the end of the question. Maybe this is about the percentage weight and weight by volume or any other thing, but the basic body of the question is going to be the same. So now let's see how many grams of sodium carbonate decahydrate contains 1000 mg of sodium. Okay, so this is the typical kind of question that comes in milliequivalents or millimoles. Milliosmoles are different. We will see about that. First, focus on millimoles and milliequivalents. So everything, every value like this, like molecular weight or atomic weight, it will be given there. You do not need to memorize it. Everything will be given there. So because this is not a test of do you know the atomic weight of sodium, this is a test of do you know how to solve the question. So from this question, you should be knowing that okay, we need to go into this mole or millimole type of procedure of solving the question. So first step here, so what has they given us? They are asking us about 1000 mg of sodium, and on the other hand they are talking about grams of sodium, this substance. So on one hand they are talking about mgs, and on the other hand they are talking about grams. What should we do first beforehand? Because I have told you to stay at one level, either stay on milli level or either stay on gram level. So what are we going to do in this particular question? Please tell me in the chat section. We should be going for the gram level or milligram level. Before even starting to solve the question, by reading the question there are two things. The answer they are demanding in grams, the answer they are demanding in grams, and they have another value given us that is in milligrams. Yes, yes, most of the people are saying grams. Why? Because sometimes when we solve the question we are too busy in the things and we forget about to changing the unit at the end. So whenever you have chance, you should stick to the units that is they are asking in the answer, because they are going to trick us here by just looking at the yes, 1000 mg is equal to 1 gram. By looking at the question, you should be seeing that okay, which level of units I am going with. So what I suggest, you can go either way, but if you go with the mgs, then at the end of the question you should be converting everything into grams. So this can be a mistake. So beforehand they are asking the answer in grams, so we will go with the grams. We will convert this 1000 mg equal to 1 gram. Okay, the first step, we write the equation. This is going to be the first step of every of these questions of millimoles, milliosmoles, equivalents, or osmoles, right? So what this equation is telling us, you do not need to worry about the other part of the formula, because this is not a theory exam, this is just an MCQ exam. We do not need to demonstrate any teacher that okay, we know, doesn't matter. Just focus on sodium, because they are only talking about sodium. We are concerned about sodium, 1000 mg of sodium. So we will only talk about sodium here. So in this equation, we got to know that now we are at the level of grams. So we will be at the level of moles, gram, mole, milligram, millimole. We are at the level of gram, so we will stay at the level of mole for now. Okay, 1 mole of this is going to give us 2 moles of sodium, because there are, and take a look, Na2. Everything that is in this subset here is going to give us 2 molecules. So 1 mole is going to give us 2 moles of sodium. Now moving forward, step 2, this is the first step. Step 2 is, because we now need to convert this 1000 mg of sodium into moles, so that we can you hear me? Anyone? Not audible. Okay, just there is an load shedding thing going on here. Okay, there was a little pause, but now we are good to go. Okay, we are moving forward. The second thing we are doing here is to convert this 1000 milligram of sodium into moles. So we have decided that we will go with grams. So we have converted this 1000 milligram into 1 gram. So we are about to know the 1 gram of sodium is going to convert into how much moles. So with the formula mass by molecular weight, put the values 1 gram and its atomic weight, because For the word molecular weight, we use this term for the whole molecule. When there is only one element, we say atomic weight. These are the same things. So we will put 23 here. So this is going to give us an answer that there are 0.043 moles that we want for sodium. Okay, with this step done, we will go on to the third step, that is simple cross multiplication. How is it going to work? 1 mole of this whole formula is giving us 2 moles of sodium. Now, how much how much moles of this formula this much moles will give? 0.043 moles. Make sense? This is a simple cross multiplication. That 1 mole is going to give us 2 moles of sodium. Then how many moles 0.043 moles of sodium will give, which is equal to this 1000, or we can say 1 gram of sodium. This should make sense. With this cross multiplication, if we solve this, this is going to give us the answer of 0.0215 moles of this whole formula. This should be there are 0.0215 moles of this formula that will give us 0.043 moles of sodium. So this is the process you are going to follow for every question, for every millimole, every milliosmole, every milli equivalent. We'll see about that in more questions, more practice questions, so it will be clear along the way. So the fourth step is again going to convert this mole into gram, because the answer they want in gram. So in the fourth step, we again apply the formula, same formula. We just manipulate it to find the mass, and this is going to give us 6.15 Gs. Where is this coming from? Moles, 0.0215 from here, and this is the molecular weight given up here, 286. So now we have found out that there are how many grams? There are 6.15 grams of sodium carbonate decahydrate contains 1000 mg of sodium. I'll repeat it one more time because this is the simplest and main body of these all type of questions. First of all, take a look at how many moles are going to give us how many moles of our desired element. There are always going to be one desired element, right? Maybe they are talking about sodium, maybe they are talking about chloride or anything. They will only talk about one thing always. So once we find out that okay, 1 mole of this molecule is going to give us 2 mole of this, so in this case, they have given us 1000 mg of sodium. So we have converted this into how much moles. Now we need to find out how, okay, now we know how much moles of this substance, our desired substance, and how much moles of the other substance they are asking about. So we will find out by just cross multiplication, and then fourth step, we need to convert it back into grams, because we can convert moles into grams and grams into moles. This is the whole story of these kind of questions. Just a conversion. We need to dive one step deep to convert it into moles, and then we need to go back from moles to grams, because the answer is always asked in grams or milligrams. I will come back here after showing you all the examples if I have to. But for now, let's move forward. The second question is going to be about MEQs, milli equivalents. Now, I have told you if the valency is equal to 1, the milli equivalent is equal to millimole, or equivalent is equal to mole, if the valency is 1. And in this question, as we see, we are talking about chloride ion. In chloride ion or chlorine, we can say the valency is 1. So this MEQ is essentially equal to millimole. All of the question is equal. The only difference it would be here if there is anything here like magnesium or calcium. So for this question, we will go just like we have gone for the millimoles. Okay, now let's see about the units. The formula of an intravenous solution calls for 25 MEQ, milli equivalents of something. Now, the other thing, given that your source of chloride will be calcium chloride anhydrous, what quantity is required in this molecular weight mgs? Okay, who is going to tell me what should be our unit level? Is this going to be gram or milligram? We should stick with the grams or mole level, or we should go with millimole and milligram level. Milligram level, because we are talking about MEQ. MEQ means we are at a milli level. I don't see any other reason to go on the gram level, so we will go with, yes, excellent. We will go with the milli levels. So how is it going to work is, number one, the statement we have here that is going to tell us is, now we are at a milli level, so we will go at milli level. So millimole, 1 millimole of this substance is going to give us 2 millimoles of chloride, right? This is very simple. Why we are talking about millimoles, because MEQ is essentially equal to millimole when the valency is 1. So one thing I want to add here, another thing is, you have to relate back to millimole. Either you are solving MEQ question, either milliosmol question, you should be consulting back to moles, because this is a single concept that you need to know, and then all of these other questions will be solved automatically. You just need to know the conversion between these two. So this system is always going to support us, mole and millimole system. So 1 millimole of this is going to give us 2 millimoles of chloride, because there are two CaCl2. So there will be two molecules of chloride. 1 millimole is going to give us 2 millimoles. Next, second step. Now take a look. In the above question here, we need to convert it into moles. But now, as we know that MEQ, when the Cl has one valency, is essentially equal to 25, same number of millimoles. So we do not need to apply the formula. The third step, same. We are going to do the cross multiplication. When one millimole of the formula is going to give us 2 millimoles of chloride, then how much of the formula will be given as by 25 millimoles of chloride. So we simply solve it. And then the fourth step, same. Now we need to convert it back from moles, millimoles into mass. So the fourth step is the same formula. We apply it, and here is an answer, 1.837.5 mg. If the required answer in case given there is grams, we can convert it easily. Now this is about the millimoles and milli equivalents. This is the main body of all the questions. Maybe some part is added at the start or at the end. Maybe they want to do another cross multiplication. Maybe they are asking you about the unit conversion. Maybe they are adding in the part per million thing. Maybe they are adding percentage weight by volume thing, which I have already discussed in the part 1. Or you can just learn those things while practicing that, okay, this is going to be the main body of the question. Now what else they want me to solve? So with this, okay, I will move forward to the milliosmol thing. Now with the milliosmol, there is one other difference with the moles and all of these things, moles and milli equivalents. Now with the where we have know about the osmolarity, right? We say that, okay, this is osmolar, this is same osmolarity of blood or not, or these kind of things. So in this milliosmoles, we are concerned about the whole formula. Previously we were only focusing on the sodium or chloride or whatever they want us to focus on, or magnesium. Here we focus on the whole formula other than the solvent. For example, if there is water, we will neglect that. Other than that, if there is a formula given NaCl, sodium chloride, we are concerned about sodium and chloride, because this is about osmolarity, right? We will see about that. So this is pretty basic. You should keep in the back of your head. We'll see in this, they calculate the number of milliosmoles present in 1 gram of sodium chloride, and the molecular weight is given. Now, I have told you that the millimoles are essentially always equal to millimole, or if there is osmol, it's going to be equal to mole. That's it. There is nothing else in this thing. So we will see about NaCl, that 1 millimole of NaCl is going to give us 1 millimole of sodium and 1 millimole of chloride. Now we should be concerned about both of these things because we are talking about osmolarity. By default, you should be considering both of these. Okay, this the same thing is about millimoles, same thing is about milliosmoles because they are same. So this is the step one. The step two is going to be convert this into millimoles. Because we have grammage given here, we need to convert it into milliosmoles. But as I have told you that milliosmoles and osmoles, millimoles and milliosmoles are okay, and you should have a basic structure of millimole in your head. This is the formula we are going to use, millimoles. This is going to be the basic structure that we are going to stand our calculations part of milli equivalent or milliosmoles on it. So behind the questions of milliosmoles and milli equivalents, there is a main engine of millimoles always. So the same formula goes here. Millimole is equal to mass by molecular weight. Just like the old questions. So we will solve it. Now we need to do the third thing, that is the cross multiplication. And in this osmolarity related questions, we will be concerned about both of these things, all of the ingredients. If there is something, some solvent like water, we just neglect that. Other than that,
समझ नहीं आती।
जी क्या समझ नहीं आ रही?
ओहो
इसको रिपीट करेंगे फिर से समझ आएगी। अच्छा, अब we will go for the cross multiplication in the third step. 1 is going to give us 2, and now we have the millimoles of sodium chloride, the whole formula. So this time we will ask 17.1 millimoles are going to give us how much millimoles of the solution. So if we solve it, this is going to give us 34.2 milliosmoles. So steps are the same almost. You will see we are at the third example, but steps are almost same. So that's it. This is the required answer. They are asking about millimoles. They are not asking to convert back into grammage. So the fourth step is missed here because we don't need it. So this is very simple. Let's take a look at another example of milliosmoles. You are required to produce a solution of calcium chloride of 200 milliosmol strength. What mass of calcium chloride do you need? So the molecular weights are always going to be here. Let's see, first of all, write down the equation and we will see first moles and milliosmoles are also going to be the same. We are going to be at the level of milli because we are in the question we are talking about milli and no other unit so far. So the first step, now we know about the equation. Now we need to miss this step, milliosmoles, because this is a simple question. We do not need to go into the conversion between mass and millimoles. This is going to be only be solved by the cross multiplication, because there is no need to go into this conversion between mass and millimoles in this question. And how you are going to determine this thing, that you are going to skip some part of this whole process. I have shown you the 4 parts. This is going to be happening with practice, because you are going to take a look at the question and then you will see, okay, what steps are required out of these 4. But or the other thing is, question is not going to move forward without the missing step. So you will know that, okay, one step is missing. So if we move forward with this cross multiplication, this is going to give us the answer of directly 66.66 moles. Let's take a look at this question again. Why we have missed the steps. You are required to produce a solution of calcium chloride of 200 milliosmol strength. So what we need is a 200 milliosmoles of calcium chloride. What mass of calcium chloride do you need? Okay, first of all, we have gone through the equation. Then we have seen, okay, we have this 200 milliosmol strength right in our hand. So we have seen that, okay, one molecule is going to give us 3 milliosmoles. Then how many, then X is going to be the result of 200 milliosmoles from here. If we solve it, this is going to give us 66.66 millimoles, and in the last step we will convert this millimoles into mass. That is, millimole is equal to mass by molecular weight. So this, with the simple calculation, they are going to be give us the answer of 9800 mg or 9.8 grams. You understand? We need to sometimes manipulate things out of these 4 steps. You just need to know the 4 steps. Okay, these are the 4 steps. Even if you try to go with the 4 in the old example manner, it won't help you in this question because there is not enough data. So the first thing is you need to know all the 4 steps that you require for. Actually, there are 3. In some questions we have turned the mass into moles or mole into mass twice. So the basic things are 3. So I have shown you 4 examples now. In the first 2, millimoles, in the last slide, millimoles and milliequivalents, things remained same. And in this question, we have, in the upper question, we have skipped the fourth point. And in this question, the question downwards, we have missed the second point. And we have gone to 1 to 3 to 4. We have missed the second point. So you just need to understand these things, and when you practice, there are going to be a lot more questions, so you will be better understanding what steps to use in what kind of questions by just looking at the question. Okay, the thing about how to solve the question is a different thing, and you will need practice to do that. Just one thing is there any confusion in the process, in the basics, the 3 basics that I have taught you to solve the questions about converting millimoles into mass and doing a cross multiplication and then converting back from millimoles to grams or mgs? That's what you have to do. Just dive deep into the moles and millimoles, then come back up with the units converted into grams or milligrams. Okay, the time is short. There is no electricity. Maybe my laptop is going to die, so we will move forward fast here, and we will take questions later. Now there is going to be another topic about suppositories. It's very simple. I have one question in my Kaps exam related to this, and it has a very simple formula. And in a whole chapter, there is only one formula for this suppository. That is weight of base of Y number of suppositories is equal to mold calibration minus drug dose divided by displacement value of drug multiplied by base density is equal to Y is the same as here, number of suppositories. So you need to memorize this formula. This thing is in bracket and there is a minus sign, not a multiply sign in here. Just memorize this formula, and how these questions are going to be solved, everything will be given you there in the question. For example, they are giving you 10 suppositories, just paste 10 here and 10 here in Y number, and they are going to give us 25 mg of PEG base. So we will be giving this 25 here. Drug dose will be given, always given here. This is in mg and required is in gram. Again, take a good look at the units used in the formulas. So we will convert it into gram, write it down here, and then we have 0.9 gram of dV. Displacement volume is given here, just write it down here, and mold calibration will be given, that is 1.6, and the density is also given 1.2. So everything is given in the question. You just need to practice a few of these kind of questions, and you're gonna memorize the formula, and you are good to go with these kind of questions. I have one of these questions appeared in my Kaps exam, and it was very easy. I don't think there is any question related to this. This is just about the formula. Now we were talking about the molecular weights. We are talking about the millimole, milliequivalents, milliosmoles. Now there is another type of question that can confuse you. For example, take a look at this question. Same like that, you have some grammage of some ingredient given, and we have some molecular weights given. Immediately your mind can say, okay, this is about millimoles, but this is not about millimoles. This you can see it in the later chapters in APEC. that these are the kind of questions that does not require diving into the moles or millimoles, and this can only come with experience, with practice, that okay, this question does not need to go deep into millimole thing, we just can solve it with cross multiplication. Let's do it. Ferrous sulfate mixture contains 300 mg. Okay, ferrous sulfate mixture contains 300 mg of ferrous sulfate per 10 ml of dose. If a person is required to take 10 ml 3 times daily of the mixture, how much elemental iron is patient ingesting daily? So we can quickly comprehend that, okay, 10 ml dose 3 times daily, there are 300 mg in 10 ml, that means 900 mg the patient is taking daily, right? Very simple. How much elemental iron is the patient ingesting daily? So patient is ingesting 30 ml daily, that contains 900 mg of ferrous sulfate mixture. Now, one thing you can see here, that the molecular weight of full formula is given and the atomic weight of iron is given. Elemental iron is also given. So we can solve this question simply by one step, that is cross multiplication. We can say, okay, 900 mg, if a patient is ingesting 900 mg of this molecular weight 278, then how much is going to be for the atomic weight of elemental iron? So very simple, 900 mg of 278 molecular weight, then how many mgs of 55.8 molecular weight? Make sense? It should be making sense, and with practice it will make sense. So if we solve it simply, it is going to give us the answer of 180.6 mg of elemental iron a patient is consuming if it's taking 900 mg of ferrous sulfate. Now, what's going to happen if you dive into the millimoles? You can solve it that way sometimes, but you need to do practice about these things. These kind of questions you can find into the later chapters of APEC. So if you are not sure about how to solve the question, try to solve it in the short way. If you cannot, then go into the long way, because there is a difference between these two type of questions, the ones we have just solved and this question. You cannot solve the older questions in the newer this way, or neither you can solve this in the older way. So there are some differences in questions, but you will find it in your practice. So just a thing I wanted to show you, that sometimes it's just about just about the cross multiplication, and you know, do not need to dive deep into the millimole things. So maybe confusing, yes, this is confusing, because this is a lot of energy, a lot of information coming right at you in a short span of time. But trust me, if you do practice, if you do all of the question types, all of the questions given in your APEC, it's going to help you. I'll move forward because of my laptop battery status. Next thing is about the child dose calculation. In this child dose calculation, we are given these 6 formulas. It's very easy. Some are related to the years of age. Some are going to be about the weight, age in months, and some are related to the body surface area. Now, how to solve these questions? You should be memorizing all of these, but depending on what type of data is in the question, you are going to select a formula from this. For example, they are giving you weight, then you will be using Clark formula, Clark rule, and this is the main important one. Most chances are you are going to encounter this in your exam, or maybe this body surface area. Or if they are giving you the age in months, use this formula. If they are giving you the age in years, use this formula. And this one, age till next birthday, this is going to be used very rarely in your calculations, but remember it anyway. For example, if there is a question where they say adult dose of drug P, for example, paracetamol is 800 mg, what is the approximate dose for a child whose body surface area is 0.53 meters square? So now body surface area is given, so use this formula. Or in another example, if they are giving you The weight in kgs, use this formula, Clark's formula. Okay, so this is pretty simple, and you need to memorize these formulas. Very easy. You write it down several times and you're gonna memorize it. Make your own mnemonics or your own shortcuts. This is not a theory question. Nobody is going to test that uh, you are memorizing this formula or not. They just care about the answer. So after this, we go into the body surface area. Body surface area, this formula is a bit tricky. Maybe you will lose these numbers in your mind that says body surface area, weight, weight uh, weight in kg to power 0.425 into height in centimeter is to power 0.725 into 71.84. So you need to memorize these three values as they are here, and at the end divide them with 1000, because we are going to convert this centimeter into meter square. That is why we need to divide it into with 10,000. So how is it going to work? A woman is 180 centimeter tall and weighs 70 kg. Another thing, if they are giving you some different units, they are testing about your conversions from kgs into pounds or maybe inches from to centimeter. So you should be memorizing those conversions. I have them in my first part of the calculations. So it's very simple. Another thing, how to write this on a calculator, that is weight 0.425. You write it down this way. To solve this question, we have 70 kgs of weight, so we can say 70. Now there is this button on your calculator. You write it down here, 70 into power 0.425 into 180 is the centimeter height into this sign, that means to power. So you just get your answer. My laptop battery is going to die, so I will be fast. The other thing is BMI. I have this question in my Kaps exam. Okay, the battery is dying. I'll I'll record the session, the remaining session, and I'll upload it on the YouTube. But we will see when it's going to die. So the BMI, just memorize this formula. You can memorize both of these. The upper one is for pounds and inches, and downside is for kilograms and meters. You just memorize the lower one and convert the unit when you are needed. Okay. Unfortunately, my battery died. There is one more thing I wanted to show you, but I think I have to stop here. Okay, light is back. Just give me a few minutes. Let me start my laptop. We will continue with the last point as well. Any questions up till now, or any difficulty you are facing? You can ask now. It's going to take a few minutes for me to set up again. Any question, everyone? No questions. Maybe this means that you are not understanding anything at all. Yeah, just the
इसकी
practice
रिकॉर्डिंग मिल
gave
जाएगी
it.
सर?
जी जी, इसकी रिकॉर्डिंग हो रही है।
क्योंकि वो मैंने सुना है, बड़ा इंटरेस्टिंग लेक्चर था, लेकिन मिस हो गया आधा, थोड़ा सा कुछ फिर लिया, फिर मिस हो गया लाइट की वजह से, इंटरनेट चला जाता है।
अच्छा, you guys are lucky. I was about to end the presentation and there is one important topic that's left, but light came back.
चलें जी, थैंक यू सर।
It's your your lucky day, man. Zoom. Okay, now that the light is back, if there is any question and you want me to go back into some question of our presentation, I can go back. Okay, we were talking about the body surface area. Okay, so this was the formula. And we have seen that to do it on a calculator, so we need to use this sign 70 and a sign that is pointing upward. This means that we are using a power tool. Okay, somebody just confirm me that you can hear me.
Yes, sir.
Okay, good. So this was
Thank
the
you,
simple.
sir.
Maybe they are asking to calculate the BSA as part of another question. So this is not going to be the simple. Maybe a question will come where they want you to calculate the BSA, but sometimes they want to calculate the body surface area as part of another question. Maybe a dose calculation, maybe there is another cross multiplication remaining at the end. But if you want to do the BSA, you follow these steps. And if you have to convert pounds into kgs or inches into centimeters, you can. Now the next thing is BMI. I have one of these questions to calculate the BMI in my Kaps exam. So there are two formulas where you can use pounds and inches, and in another formula you can use kilograms and meters. There is this 703. 703 you need to memorize if you go for units and inches. So you can go with both, or you can go with one. That is this one, simpler: height, weight in kilograms, and height square in meters. Okay, take a look at this square. On a calculator, there is a button for square calculation. And another thing I want to add is that you need to take one scientific calculator with you. They will allow you. There is no restriction on that. And do not just rely on the calculator that's in the computer. It's terrible. It's going to take a lot of time of yours to calculate things. If they are going to give you 20 calculations, then you should be having a scientific calculator on your table. Otherwise, it's gonna be hard. So you can memorize both of these formulas or a single this metric system formula. And if the value comes in pounds and inches, you just simply convert them into kgs and meters. It will work. So this is just about the simple formulas and how you are going to calculate it on your calculator. Now the last part is about the stock solution. This stock solution formula is going to solve two problems. Number one, if you are going to check what is the actual concentration in stock solution, in which we have taken dilution, we have made another dilution, and that what is the resulting concentration. Or we can also see the resulting concentration. We can take resulting concentration as X or initial stock concentration as X. Both of these things can work. In a question, if they ask you what is the original concentration or what is the concentration of stock solution, or they can ask you about what is the resulting concentration. Both of these in space of 5 mg or 1 mg can be X. All of the values would be given. If any one of these value is missing, you can place X here and calculate it. So how is it working? First of all, we have initial concentration or stock solution. That says it has 5 mg in 10 ml. Then there are these dilution factors. So in the question, we will see the question in a moment. If they say that out of this solution, we take 1 ml and dilute it into 20 ml. Then again, we take 1 into 8. This is a factor actually. Sometimes they say, okay, dilute it 1 by 8. So we can use both of these things. That's why I have shown you here that even if they say dilute 1 ml to 20 ml, you just put it here like this. Even if they say in a question dilute it 1 to 8, you simply put 1 to 8 here. It's gonna work. And is equal to sign, and then this is the final concentration. This is resulting 1 mg into 10 ml. This is not right mathematically. It's fictitious values. We will see about the original values in the examples. So any of these can be X, the concentration of initial or stock solution or concentration of resulting solution. The units should be the same. Now there is something about the units here. You should see mgs and ml only here. We are talking about mg or ml. We are not talking about gram in somewhere here. If we are going to talk about grams, then everything should be in gram. For example, in a question, if they are mentioning grams 3 times and milligram 1 time, then convert that milligram into gram. Just stay on one level in here. Either go with liters, either go with milliliters, microliters, but you should be using one throughout. For the other values, you need to convert. If there is one value that is not resonating with this level, just make it up to that unit. So this is going to be the example question. How many milligrams of terbutaline sulfate would be required to prepare 100 ml of a solution? First thing, we got our first thing, that is wait a second, let me just write it down. So from the first line, we have gained that how many milligrams of terbutaline sulfate would be required to prepare 100 ml of a solution. That means how many milligrams in 100 ml. They are talking about a solution 100 milligram in 100 ml. So this is the first part, X mgs in 100 ml. Next, such that when 1 ml is diluted to 5 ml, multiply, place the dilution factor here. 1 ml is diluted into 5 ml. A final concentration of 500 mcg per ml would be produced. So what is the concentration given here? 500 mcg per ml. Per ml, this is 1 ml. And we need to convert 500 mcg into mg because we are dealing with mgs now. We will convert it 500 mcg, that would be 0.5 mg. So this is the simple way to put the values here. Even if they give you multiple dilutions, they after this dilution, 1 into 5, they say, okay, do another 1 into 10. So you just multiply it here and add 1 into 10. It can work. The number of dilutions is flexible here. So if we try to solve this question here, the x is here at the left side of the stock solution. So the answer is 250 mg. Just be sure of the units. The formula is very simple. Now let's take a look at another example in which they have used another type of dilution, that would be 1 to 8 dilution. Just a moment, guys. Okay, thank God. Okay, in this question type, they are saying how much atropine sulfate is required. Just forget about this part. To prepare 100 ml, how much of this is required to prepare 100 ml of a concentration solution? Now, they are not giving us any unit here. How much atropine sulfate? They are not giving us mgs. They are not giving us grammage. So we are at liberty. We will see what unit we are going to use for the question. And then again, we will see what unit is given in the answer. It's a separate thing. So for here, we'll move forward. They are talking about mLs. So let's say we say mg here. Yani x mg in 100 ml of a concentrated solution such that when diluted 1 to 10. So this was the thing I want to tell you. Sometimes they say dilute 1 in 10. So you can put it simply 1 by 10. Even they can mix things. They can say, like in the question above, 1 ml is diluted to 5 ml. Again, they can say, again, make a dilution of 1 in 10. So we can add two things here as well. Just add another multiplication and 1 in 10 right there. The resulting solution has a concentration of 1 mg per 10 ml. So here 1 mg divided by 10 ml. So this is simple thing, but expect a few questions, at least I think one question like this in your CAPS exam. So if you solve this, we will get the answer of 100 mcg. Now that they have not given us any unit here of how much atropine sulfate, we will look at the answer. Either they want the answer in milligrams or grams. So we will convert it likewise. So with this formula, you can, in these two questions, we are solving the concentration in stock solution or the main first solution. In some question, they might ask you about the resulting concentration as well. They can give you a concentration start. For example, they say 250 mg per 100 ml, then you make a dilution of 1 in 5. That can give you resulting concentration of X of what is the concentration, how much mg is in 1 ml. In that case, you put everything just like this, just put X here and you solve it with the x here. So you just manipulate the whole equation according to the x on this side, on right side, and you will get the resulting concentration as well. So these are the 7 topics. The recording will be available on YouTube. You can watch it there and you practice. With practice comes perfection. Where when you are doing practice, for example, you do one kind of questions, millimoles or milliosmol questions, the full chapter, and you do it multiple times, they are going to be on your fingertips. What about allegation method? It's important. Yes, it is important. Expect some questions from allegation method. Thank you for attending everyone. Practice will make you perfect. There is no shortcut. For example, there are two kind of solving different questions that seems the same. Like the questions that I have shown you that can only be solved with cross multiplication. There were given some, yeah, recording will be available. They were given some elements like molecular weights that can confuse you that, okay, we have to go deep into the millimoles, but you don't. So with practice, these things will get clear. I think nobody have question. Prove me wrong here. Okay, Mohammad Waqas.
जी अस्सलाम वालेकुम।
जी वालेकुम सलाम।
अच्छा समी भाई, हमने ये डाइल्यूशन मेथड किया है, तो इसमें आप बता रहे थे कि डाइल्यूशंस मतलब कि दो भी हो सकती हैं, तो वो मैंने मैसेज भी किया था कि मैक्सिमम दो ही हो सकती हैं या वो तीन चार या इस तरह से भी कोई होता है?
वो ज्यादा भी दे दें।
अच्छा, मतलब मोर देन टू हो सकती हैं।
हाँ, वो ज्यादा तो होंगी नहीं, मतलब बात बताऊं आपको, कैप्स
जी जी।
एग्जाम के अंदर ना आपको ऐसी कैलकुलेशंस आने वाली हैं जो आप 1-2 मिनट के अंदर सॉल्व कर लें। अब वो इस
ओके।
तरह का ट्रिक आपको दे सकते हैं कि यार, यानी कि अगर तो आपको पता है जैसे कि 1 मिलीमोल के अंदर इक्विवेलेंट ग्राम ही होते हैं जो आपका मॉलिक्यूलर वेट होता है, इस तरह की चीज़ों में आपको थोड़ा घुमा दें बस। अगर आपको इस तरह की चीज़ें पता हैं तो कुछ भी नहीं है, तो वो 1-2 मिनट के अंदर सारी कैलकुलेशन सॉल्व हो जाती है। ये जो यूट्यूब है ये सर इरफान का होगा जी। सर इरफान का यूट्यूब पे ये जूम भी सर इरफान का ही है और डायरेक्टली ये उधर यूट्यूब पे अपलोड हो जाएगा। एनी अदर क्वेश्चन? Getting the slides, okay, I will share this presentation. I have to see if there is any sharing option because I'm using a free version here. What's your YouTube? Yeah, the YouTube channel is going to be the Sarir Fan's YouTube channel. Okay, how many of you want to discuss the CAPS exam? Because we have not done any session about CAPS. We have only 22 participants here. I think the 18-20 are the genuine participants. Other are the admins. If you want to ask anything, I can give you time. Openly about CAPS exam because we have not done any session particularly for preparation. There is not going to be next class of calculations. There are other type of questions as well. Yes, there are biopharmaceutics related questions, but they only rely on formulas. There is no need to deep understand those things. So that's why I'm not making a presentation for that. I am getting lost into my own life now. I was promised I promised that I'll make more on calculation, so that's why I'm making it here. How much time required for preparation of all topics of CAPS? I think 2 months are enough if a person is giving full time. Yes, if you want to ask about CAPS exam, can you be more specific about the CAPS pattern or what? You can come on you can come on mic. Could you go through Allah Nasser recall in one session? It will be great help. No, I think it's not possible. Allah Nasser are very deep. But one thing I tell you about Allah Nasser recalls. One person is asking about, can we go through Allah Nasser recalls in one session? What's going to happen? There are a lot of details that are missing in Allah Nasser recalls. So let me reiterate what is a recall. Recall is actually what happens is that I sit in an exam, I will come outside. The actual exam statement is like 3 to 4 sentences, and answer statement is also 2 to 3 sentences. What I will remember is that okay, something was related to sodium channels, and the answer was potassium, for example. So this is the thing I remember. So I write it down. I share it with my friends. So this is what the recall is. It's not a full question, not a full answer. Just a hint of the question, just a hint of the answer. So whatever there is on Allah Nasser recall, just memorize it. And when it's going to come in your CAPS exam, if you remember the recall, you are gonna remember that okay, this was the question from the recall, and this is going to be the answer, because the person who have shared the recall has shared the main part of the question and answer. So sometimes you see that okay, this doesn't make sense. Okay, we have found a mistake in a lesser recall, but what's going to happen is in the actual exam there may be a word at the end of the question that says except, that is turning the whole sentence upside down. So you just don't go into the deep research in LLSR recalls, just remember them. And these are the questions that are going to appear exactly in your Pearson system. So just memorize it. There is no need to go deep into these recalls. Just memorize, okay, this is the question, this is the answer. And how good you should be remembering this. you should only be reading the question and hiding the answer, and you should know the answer. What sort of our preparation plan should be, whether book basis or recall basis of recalls, then which ones? Okay, actually the paper is from recalls. Paper from recall is about 60%, 70%, 30%. Most of the people encounter new questions. They enter new questions into the pool. To encounter the 70% of the previous questions, you do the recalls. And this is a short version of our preparation. And to deal with the 30% remaining, maybe a person is unlucky and he got more, maybe 60, 70 because recalls and we don't know what they're gonna ask. And which recalls? The important recalls are Ala Nasser, Lara recalls, Hamdi recalls. These are most important ones. The rest of the others, you can go with Nazir Rafiq files that contains July recalls. The recalls from the November are also in process. The file is not prepared yet because it should be up to the people of November to compile the recalls, but I think they haven't. But you will find a file soon about the November recalls. These two recalls files, Al Nasser recalls, Hamdi recalls, and I think these are the backbone. Other recalls you can memorize according to your capacity and time. Repeat once about the total preparation. Okay, let me give you a quick recall about the whole question pattern. So paper one is going to be the pharmacology. No, just recall names, recalls name. Okay, Ala Nasser recalls, Nazia Rafiq recalls, Hamdi recalls, and the one you will find for the November ones. I don't know the file name yet, but these are the most important ones. You should be starting from these. You should be memorizing these at your best, and the other recalls files according to your capacity. The paper one is going to be about the pharmacology and chemistry. Let's talk about the pharmacology. These are going to be the straightforward short questions, short answers. They will be asking you about pharmacology like classification, mechanism of action, short questions, short answers. In chemistry portion, they will be asking you about, yes, you're right, Alana Sarlara, Hamdi, Nazia Rafiq. In chemistry portion, they will be asking you now less about structures. Just a few times in the last exams, they are asking less about structures, but the structures at the end of Al Nasser recalls and 2 to 3 notes files we have shared about chemistry. You do that, it will include stereochemistry, it will include some theory about chemistry, and it will include structures and ring structures. I'll try to make a video on ring structures. There are 24 or 30 ring structures that you need to know, because they ask about, okay, this ring structure is in which drug, then they give a few drug names. So these kind of questions you can expect, and you can also see it in reports. Now this chemistry portion is not difficult because chemistry theory is easy. You will see in the notes. The next paper is about pharmaceutics and therapeutics. The therapeutics is going to be easy because we combine the therapeutics with pharmacology. We study it combined, and we also have recalls at our side. So this is not going to be a big problem. From the books, we study, from the CPR, we study about therapeutics. From the pharmaceutics portion, this is a tricky one. Most people get stuck in this pharmaceutics portion. How? Pharmaceutics contain pharmaceutics questions, theory questions, and this is really a detailed topic about different type of stability test, quality controls, and some basic pharmaceutics, how to formulate things, what is there going to be the queue of adding ingredients in a formulation, these kind of questions. And the other thing is about, in the pharmaceutics portion, calculations. Now, in the last few exams, I have myself experienced that the calculation questions are rising, and maybe there are some people who have not actually got a single question of pharmaceutics theory. They only got calculations. So if you have good command on calculations, this is going to be a good thing, because pharmaceutics theory is a really deep topic. really deep topic and very dry topic. So if they give you more calculations, you are lucky. You should have a good grip on calculations. So you are going to ace this thing. That's it. It's not that deep. You make it complex for yourself. It's not good. These are the simple things. You keep it simple. Any other detailed or specific question? From where we should cover Sutik's theory from the CPR chapter 2 and other from the notes. The new CPR version is have a chapter 2 of pharmaceutics. Okay guys, that's it. I think the more questions can come in group. The recording once uploaded on YouTube, you will find a link in the group and you can find it directly on Sir Irfan's YouTube channel. Thank you very much everyone. Thank you for attending and thank you for understanding. Thank you very much everyone.
Thank you, sir.
Welcome.